Hi guys, welcome back to our video series for ladder logic programming. And today I choose to coming back to the timers because when I tried to complete a series with different kind of projects from our real life problem, so I found timers and counters playing the crucial part of programming in ladder logic. So I want today to showing the most important three timers and how we can doing or playing with the timers to solving the different kind of problems. So let's today to need of timers of the these types, and what is the bits related to how many what is important bits related to the timer. We call it timer bits, and also the different variable related to timers and techniques also that we use to initiate the timer or reset the timer, or using the different variable of the timer. So let's getting started to our video. And so without any further delay, so let's jump into our video here. So I'm starting directly with a ladder logic sample program. So the first important timer is the on delay timer, and we don't all of us, I think, know what's the difference between the timing in on delay and off delay, or the retentive delay, but we review it today to make sure you and me in the same page, guys. So on delay timer, we're starting the timer, and the timer, when the timer starting running, so the timer done bit it will be turned on after the preset value has set. So when you see the block of the timer here, which is a T on, so the timer needs one input. So everything on the left hand side of the rung of the T on, it will be considered as an input. So if this RTO is on, which we call it the logic before or on the left hand side, if it is true, so the timer will count start timing. So by the count start timing, the bit of TT, we called it a timing bit, will start to be on until we're reaching to the preset value. So we have here the preset value. So we set the preset value in a multiplication between the preset value and the time base. So here, if we put the time base to 0.1 and we put the preset value to 100, that means 100 by multiply 0.1, so it is for 10 seconds. And we can make also the time base to be 1 to count in 1 second, 0.1 to count on 1/10 second, or 0.01 to count 1/100 of second, and so on. So here for 10 seconds, once the input to the timer comes to true, so the timing bit will start to be on, and the timer start counts or timing until reaching to the preset value, which will be after 10 seconds here. And you can see also the last one and the third one, which is the accum, like the accumulator, which is accumulating the time, and once the accum reaching to the value of the preset value, so the timing bit will be turned into on. And once it's be greater than the accum, greater than the preset value, so it will be turns off. That means no longer timing, it's stop timing, because it's reaching to the designated value for timer. So on the right hand of the block of the timer, you can see two things, which is EN. That means EN meaning enable. So that means this block of timing already completed. And the done bit, this done bit meaning the timer counter accumulator reaching to the preset value, and the timer now is the timer done bit now is on. So here in the other rungs, to show the difference between EN and the done bit and TT bit, so we here using the timer bit to enable three different kind of output: Q2 0, Q2 1, Q2 2. So let's go to our simulation before going any further in timing to simulate this block and see. So here in the page for the simulator for the RS Logic 500, you can see on the left tab very fast to make you recap what's here in this tools for RS Logic Logic 500. So you can see here the controller and the IOs and the channel configuration. You can, guys, like when you have this program, you can navigate this part on the left to see what's about this, and you can hit help and see. This is like, for example, this is the configuration. You can see all input output devices. You can see all the different kind of communication channel, input output, digital input, digital output, analog input, analog output. You can go through this thing to see. And also here you can see this is the related to the processor type and so on, compiler password, so something like this. So also here this is a channel configuration, and this is a program file for sure. So this is the programs. So you have here starting from ladder 2, this is the first program, and this is the subroutine. You can write here subroutine, and by calling this subroutine, you can call this some subroutine here. We will show you in the next. So moving to the our logic here. So I need to show here in the data file. You can see the output that you have connected here, and the bits for the output. Like you can see, this is 16-bit from 0 to 15 for each output. Same thing for the input here. You can see here the input, like 16 input bits for the input, and also this is the status flags or the status words and the binary. And moving to the timer here, so we have here in RS Logic, we have the timers starting from T4 0. This is one timer, and 1 2 3 4 5, this is all the timers we have. So we have many timers. We can use any of these timers, okay, through along your project. So here we starting with T4, we will use T4 0 for example, and for each timer you can see here is the enable that I showed you here. The enable is the showing the block of the timer is completed, and TT is showing the timing bit, and also timing bit, and the done timer done bit, and the preset value you set, and the accumulation value while timer is running or counts. So that the accumulation will showing you the bit. So let's starting with putting one block here, but before starting this blocking, let's see the IOs here. So I will have this IO simulator to showing you this thing. So now let's see. Yeah, so this is the timer and this is the simulator. We need to make it open for the IO simulator, but I don't know why the window is not showing. So let's close this one or close this one. I don't want to close the program itself. So here, like okay. So guys, here let's move to the one input, and we put a block for the timer. So going here to the timer to using the T on. So as you can see here, I can put here one input, but I want to show you the IO. Still, I want to show you the IO itself. So I can put it here like I0, okay, I0. Okay, I0, so 0 0, okay, and I can also put here the configuration for the timer. So this is the timer configuration. So the timer, I will select T4 0. This is the timer that I gonna use. T4 2, I'm sorry, and this is the time base. I can put the time base whatever I want to set. I can changing this to any one of those, okay, and I can also preset for this for 100 will be multiplied with the time base 0.1. So this for 10 seconds, and this accumulator to see what's going on in this thing. Okay, and then I will using the timer bit to enable the timer. See here the output that I'm showing you. So here I'm using this one, so I will use the timing bit. So I will using this is one output here, so I will use this output here. Let's make another rank. So moving to the other rank like this, another one, so I can using this is one output here. Okay, so this is one output, and I can put another rank. Okay, so I can using this one for sure, and another one like this one. It will be like this one. So I have 3 bit here, but I can delete this one, no need for this one. So cut this rank, and also I can cut this rank. So now for sure we have 3 output. I can put this output like this to showing the difference here. This is one output, auto 0, auto 1, and auto 3. Okay, and using the timing bit which will be the T4 4 dot ACC. I'm sorry, it will be this is the timing bit, so I will show you the timing bit like this is the TT. So once I starting, I'm sorry, this is okay, this is 4 at TT, I think, yeah. So once I starting timing by enabling this input, so timing bit now is on, and this count will be set, and by reaching to the this is for enable after completing, but before enable, let's say using the T4 for slash DN, this is a done bit, and finally when this timer ended up, so the enable it will be on. So this is for this. So let's see here the output of this program. So once we're starting with enable this one like this, so you can see guys here, once I enable the I0, okay, I10, I need I10, not I00. So let's see, let's modify this one to be I10. Okay, like I'm sorry, take this one here. Okay, I10, and download again and see. So once I enable this one, so once I enable the input to the timer, so you will find the timer counts. You can see accumulation here counts, but this one which is timing, so this output is on, and the done bit for the block is on, and this one after reaching to 100 accumulation equal to the preset value. So you can see here the TT stop timing. That's why that output is off, and the output of this one, which is a dumb bit now, because the preset the accumulator reaches to the value of the preset value. So that output is on, and this is everything related to this timer. So moving to the other type of timer. But before moving to other type of timer, so here you can see here, if I make this one in the other side like this, okay, and make this one to be enabled like this. So here guys, I want to show you here if we go into the data and timer. So this timer is our timer. We're using this timer, which is T44, and you can see here the enable is on. You can see here the TT no longer counting. You will see here the done bit is on, and you can see the preset value and accumulation value equal 100. And let's try to reset this counting again. So you can see here guys, once I enable this one, so now you can see if I set this one to be off, like this is the input data for I10. So I10 now is on, so I bit it 0. Okay, so I need to go into the simulation. So once I go into the simulation again here and make this open, and then make this again on, and very fast I'm moving to the data here for the timer bit. You found here accumulator counting until reaching to 100, and once reaching to 100 the dump bit going to on. So that's for showing everything in the data file of the RS logic, and also how to using the different bits of timer to be used to enable activating output, which are the most important bits, which are the timing bit, the dump bit, timer dump bit, and the enable bit. Thank you guys for watching, and next time we'll go in to the next part of this video, because it is very important to understand of the timer. So next time I will show you how to reset the timer or make the timer to reset itself. And this technique very important for you to let things like based on timer to be repeated more and more forever by resetting the timer to repeat the cycles that based on timing technique. Thank you for watching guys, and let's meet to another one. Goodbye.